Hello everyone and welcome back. My name is Mr. Cobalt, and in this video I'm going to show you how to find the molecular formula of a compound. So let's get into this. So the first thing you need to do when you're given a problem like this, where you're presented with the percentages of the elements in your compound, you have to find the empirical formula first. If you don't know how to find the empirical formula, then please go to my videos where I go over several examples and explain how to find the empirical formula. So you'll have to do that first. So in this video, we'll have to find the empirical formula, and then we're going to find the molecular formula using the molar mass. So the difference between a problem that's asking you for the empirical formula and a problem that's asking you for the molecular formula is that in the problem that's asking you for the molecular formula, you have to be given the molecular mass or the molar mass of the substance itself. Without that, you can't find the molecular formula. And the reason they want you to find the molecular formula, the reason they give you the molar mass or the molecular mass of the substance itself, the molecular substance, is because once you find the empirical formula, you know that the difference between the empirical formula and the molecular formula is a factor of some whole number, right? So, for example, just to remind ourselves, if I have glucose C6H12O6, that is the molecular formula. The empirical formula for this substance is CH2O, right? So this is the empirical formula. This is the molecular formula. The difference between these two is a factor of 6. If I multiply this by 6, then I get the molecular formula. Well, the thing is, if the formulas differ by a factor of 6, so do their masses. The formula masses will differ by the same factor. So if I know the molar mass or the molecular mass or the formula mass of my molecular substance, then I can once I find the empirical formula, then I can calculate the formula mass of the empirical formula and compare that to the given mass and see what the factor is between them. If they're equal to each other, then the molecular formula and the empirical formula are identical. But if they differ by some factor, then I need to use that factor to multiply my empirical formula to get the molecular formula. Okay, so I know that was really wordy for an introduction, but let's go through these problems and I'll show you what I'm talking about. So let's get into this. So here I'm giving percentages, so I need to find the empirical formula first. So I'm going to start by converting these to grams because I'm assuming 100 grams of my compound, and these will then convert to grams. So I'll have 53.31 grams of carbon, and I'll have 11.18 grams of hydrogen and 35.51 grams of oxygen. Now I'm going to multiply each of those by its molar mass. So carbon is 12.011 grams of carbon per 1 mole of carbon. So grams cancels out. And I get moles. And when I calculate that, I get the moles. Let's see, 4.438. So this gives me 4.438 moles of carbon. Next, I'm going to multiply hydrogen by its molar mass. That's going to be 1.008 grams of hydrogen on the bottom, and I get 1 mole of hydrogen on top. The grams cancel out, and when I calculate that, I get 11.09 moles. So 11.09 moles of hydrogen. And then finally, I do oxygen. So I'm going to multiply by the conversion factor of oxygen, the molar mass, and that's going to be 15.9994 grams of oxygen on the bottom, 1 mole of oxygen on top. Grams of oxygen cancel out. And when I divide that, I get 2.219. 2.219, moles of oxygen. So now I have the moles. Now I can put this in my pseudo formula as subscripts. So here I'm going to have carbon 4.438, and then I have hydrogen, which is 11.09, and then I have oxygen as 2.219. So now I have my mole ratio, but the moles are not in whole numbers. So I gotta get these into a 1 to something ratio. So I'm gonna divide by the smallest one. So the smallest one is 2.219. So I'm gonna divide all of these by 2.219. 2.219, divide this by 2.219. So now when I divide these, I get 2 moles. So here I get 2. If I divide this for the hydrogen, I get 2 approximately 5, very close to 5. So I'm rounding this to 5. And then, of course, oxygen is 1. So divided by itself is 1. So that is the empirical formula. But I want the molecular formula. So I have this. So what I need to do is compare the molecular formula mass to the empirical formula mass. So when I add these together to get the empirical formula mass, I get, let's see, 45.061. So this is equal to 45.061 grams per mole, or whatever the unit you want to use. It doesn't matter because we're going to compare the two, right? So here I get 45.061. The actual mass of the molecular formula is 90.112. So what I'm going to do is I need to get the factor. So I'm going to take the molecular mass, 90.112. That's the larger one. I'm going to divide by the smaller one, which is your formula mass, the empirical formula mass. So that's 45.061. And I basically get a factor of 2. So that tells me that in order to get the molecular formula, I need to multiply my empirical formula by a factor 2. All of the subscripts have to be multiplied by 2. When I do that, I get C4. 2 times 5 is 10, so H10. And then 1 times 2 is 2, so O2. This, ladies and gentlemen, is the molecular formula of my substance. Let's go on to the next problem. So here, again, I'm given some percentages of the elements in my compound, and I'm given the molecular mass. So I do it all over again. So first, I need to find the empirical formula. So they give me percentages. I need to get grams. So I'm going to assume that I have 100 grams of my compound. So if I do, then these percentages just become grams. So I'll have 39.94 grams of carbon. I'll have 1.12 grams of hydrogen. And then I'll have 58.94. Who's that? 94? Yeah, 94 grams of chlorine. So again, I'm going to use the molar mass of each element to convert to moles. So again, I'm going to multiply by the molar mass of carbon, 12.011 grams of carbon. And then I have 1 mole of carbon. Grams cancel out. So I'm going to calculate the molar mass. And when I calculate that, I get 3.325. So this is 3.325 moles of carbon. Again, do the same thing with hydrogen. So I'm going to multiply that by the conversion factor of its molar mass. So then 1.008 grams of hydrogen on the bottom. And then I have 1 mole of hydrogen on top, so grams cancels out. And when I calculate that out, I get 1.111 moles of hydrogen. And again, chlorine, I'm going to use the molar mass of chlorine as a conversion factor. So that's going to be 35.45 grams of chlorine. And then 1 mole of chlorine on top. So grams of chlorine cancel out. And when I do that, I get 1.663 moles of my chlorine. Okay, so now that I have moles, I can go to my pseudo formula and write the moles as subscripts. So I'm going to have C, and that's going to be 3.325. And then I have hydrogen, that's going to be 1.111. And then I have chlorine, 1.663, 1.663. So there's my pseudo formula. And again, these are my mole ratios, but they're ugly because these are not in whole number ratio. So I'm going to divide by the smallest one, which is 1.111. So if I divide everything by 1.111, right, I'll get closer to whole numbers. Hopefully I get whole numbers, but if I get a fraction, I can multiply that out. So let's see what happens. So if I divide this by 1.111, I get, let's see here, okay, that's going to be 2.99. So 2.99 is very close to 3. So if I write that out, 2.99, right? We'll just leave that there. This will be 1. So that's going to be 1. So, and then 1.663 divided by 1.111 gives me 1.496. 1.496, right? So you can see that this is really close to 1.5, right? So we could just round that to 1.5, right? And this is really close to 3, so we could round that to 3 easily. So that's 3. And now we have this half, this obvious half. So we can then multiply this by 2 to get our empirical formula. So to get rid of the half, we need to multiply by 2, but then we need to multiply all our subscripts by 2. So 3 times 2 is 6, so we have C6. And then we multiply 1 by 2, so we have H2. And then we multiply 1.5 by 2, and that's going to give us a 3, so Cl3. So that is, ladies and gentlemen, our empirical formula. But again, we want to find the molecular formula. So we need to calculate the molar mass or the formula mass of our empirical formula and compare that to the molecular mass or the molecular formula mass that they gave us. So when we calculate this formula mass, we get 180,432. So this is going to be equal to 180,432. So now what we can do is divide the molar mass, the molecular formula mass that they give us by this. So then we get 360.88. We're going to divide that by 180.432. And you can basically see, you probably don't need to calculate this. You can see that this is going to be a factor of 2. So this is going to be equal to 2. So again, to get the molecular formula, we just multiply all the subscripts by 2 to get the molecular formula. And when we do that, we get 2 times 6 is 12, so C12. 2 times 2 is 4, so H4. And then 3 times 2 is 6, so Cl6. So that, ladies and gentlemen, is the molecular formula for this substance. That's it for this video. I hope you enjoyed this video. If this was helpful in any way, then please like the video, share the video, hit that like button over there. Also, make sure you subscribe to my channel, hit that notification bell so that way when I post a video, you can be notified by that video. Make sure you click all though. And then finally, put a comment down below in the comment section. Let me know what you think. Ask me questions. I would love to hear from you. If you have a topic you want me to cover in a video, if you have a question or a problem you want me to solve, then please let me know. I would love to do that for you. Thanks for joining me and have a great day.